Good evening, viewers. Welcome to today's live episode, new episode of My Teacher, the UAE's biggest classroom. So I hope you have enjoyed a lot yesterday night to celebrate or to welcome the new year. Today we are in the new year 2015. So hope let's all have a prosperous year this year as well as we had last year, and let's wish that the year coming, the 2015 would give us a lot of prosperities and positive energies to us. Today's program, My Teacher, it's a live program. Today I thought of discussing something related to class 10 physics. Last few episodes we have been having classes for class 12 physics. Today I thought we will go ahead with some contents of class 10 as well. So I request the parents and the students who are studying in grade 10 to tune into this program for the coming hour. So in case if you have got any doubts related to the contents we discuss, you may please call us. You can see the live number given at the bottom of the screen. So again, welcome you and wishing you again a very happy new year. We will move on to the contents of today's session. So you must be aware of this program, My Teacher. Every day 5 o'clock we have the live sessions for the classes, especially focusing the Indian curriculum of various subjects, and as I promised, today we will move on to some concepts of grade 10 physics. So I welcome the grade 10 students who are studying in UAE to watch this program, and of course while discussing, if you find any confusions anywhere, if you want some more clarifications, you please get back to us. You can call us straight. You take the phone and call us. I will be able to address your queries. In fact, in this today's episode, I thought of dividing this into two segments. First segment, I will brief you the concepts of what you have, some chapters in 10th physics, and second half we will discuss some questions related to board examinations. So I hope it is clear. In one of the chapters, or the basic concepts of what we have in physics in grade 10 is related to light. The light specifically we have in the syllabus, if you look at, you can make out concepts of reflection, refraction, scattering, mirrors, lenses, then the phenomenon of dispersion and human eye, defects of human eye, and numerical problems related to those concepts. Those are the areas we have in the syllabus of class 10 in this part, in this segment, of which reflection you must be well familiar with. We have a lot of examples of reflection, and related to reflection we have the case of mirrors, spherical mirrors, concave mirror, convex mirror, then the terms related to that, all these you must be familiar with. And there is mirror equation and the term magnification, right? So all these you must be familiar with. Second part is refraction. Refraction, very common examples we can see in refraction. Typical cases like you go to swimming pool. When you look at the pool, you may be able to you may think that okay, it is less deep only, so you may jump into it. When you jump only, you will actually come to know how deep it is. So the pool appears to be shallower than actually it is. That's an example of refraction. Another refraction, the case of you must be aware of this fact, like about delay of sunset and early sunrise. That's due to atmospheric refraction. So refraction is the term to first understand. Refraction. Then we have another example. Can you make out another example for refraction? I gave you two examples. Another one is that again you must be well clear with, that is the twinkling of stars. Twinkling of stars also due to the refraction through the different layers of atmosphere. When the light rays are passing through the layers of different densities, we say there is refraction, due to which we can see that the stars appear moving. Twinkling of stars is due to atmospheric refraction. So these are some of the examples. Anyway, in refraction, let us look into the concept of refraction in detail, little more detail. What is refraction? When light goes from one medium to another, having different optical densities, we will see that the ray will bend away from its original direction. So this phenomenon of bending of light when passes from one medium to another, having different optical densities, is what is termed as refraction. Clear? This refraction is in fact leads to the case of we have the laws of refraction. There are 2 points we have under laws of refraction. The first point, we know the incident ray, refracted ray, all those on the same plane, that's one thing. Then we have the case of Snell's law, which says sine of the angle of incidence to sine of angle of refraction is a constant. You must be familiar with the term, the constant. What is that constant called? That is called refractive index of the medium. Which medium? The second medium with respect to the first medium. So there are 2 ways we express about refractive index. You must be familiar with the equation like sin I by sin r. N is equal to, see, when I write n to 1 is equal to sin I by sin r. What does this mean? How do you read it out? Refractive index of second medium with respect to the first medium is sin of I by sin of r. I comes in the first medium, r comes in the second medium. So when you simply write Ng, what does this mean? Refractive index of glass. You know what it is with respect to? If you simply say refractive index of glass, it means with respect to air. Such a refractive index is what is termed as absolute refractive index. But when you say refractive index of glass with respect to water, when it is going from glass to water, let's say, or water to glass, when it is going from water to glass, then the refractive index, when you calculate it, is refractive index of glass with respect to water. Such a way, if you express refractive index, that is called relative refractive index. So I said laws of refraction, from which we got the term refractive index. 2 ways we express refractive index, that is absolute refractive index and relative refractive index. Then when it passes through a prism again, there will be deviation of light. Okay, so the refraction you understood, I hope so, right? Refraction. So what is refraction due to basically? So you know, when light enters from one medium to another, you know, different media, light rays have got different speeds. So when light goes from one medium to another, due to the sudden change in the speed in the what you say on the surface of separation of the 2 media, you will see that the light gets deviated from its path. So basic reason for the refraction is the various speeds of light in various media. Different medium, light possesses different speeds. That is how we have another equation for refractive index. Instead of, or in addition to sin I by sin r, we have another equation, light, that is refractive index is equal to speed of light in vacuum or air to the speed of light in medium, C by V. That's another equation we have for refractive index. Alright, so refractive index, then it leads to what you call as lenses. We have 2 types of, before going to the concepts of lenses, I will show you a small demonstration about refraction. You please watch the monitor, look at the monitor. You can see about refraction. So now I will send a light ray from this source. You see this angle is what is called angle of incidence, whereas the angle between the refracted ray and the normal, this angle is angle of refraction. So this is angle of refraction, this is angle of incidence. So if I change the angle of incidence, see, I am increasing the angle of incidence. What do we see? When angle of incidence increases, angle of refraction also increases. But this medium, it can also be seen that there is a reflected ray as well. This is reflected ray, and what is going down, this is the refracted ray. So the ray is going from which medium to which medium? Rarer medium to denser medium. You see, I have chosen this as air, to water it is. Now if it is air to glass, see, again more deviation would be there. because refractive index of glass is more, right. If it is going from glass to glass, you see there is no deviation. If it is going from glass to water, you see how it bends away from the normal. So, you can see that light enters from denser medium to rarer medium, it will bend away from the normal. If it is from rarer to denser, that is say for example air to water, you can see it is bending towards the normal. You see it is closer to the normal. This is normal, correct. Now again another thing what I will show is, through a prism when light ray passes, see how it is. I have a, see I am using a triangular prism here. So in a triangular prism, if I am sending the light ray, you see how it is. You can see as the angle of incidence increases, you can make out one thing. Here if you draw a normal, this is what you call as this angle is angle of incidence. Here we have outside angle, that is angle of emergence. The diagram you must be familiar with, and instead of that, if I replace it with a rectangle glass slab, how it happens you can make out. See, this is a concept of rectangular glass slab. See, in a rectangle glass slab, again another aspect to understand is, you can see here there is angle of incidence, here there is angle of emergence. You can make out that angle of incidence and angle of emergence are equal. So once again, that is, this is concept of refraction what is shown here, refraction, okay, and along with you can even make out what's reflection as well. So remember, light enters from rarer to denser medium, will bend towards the normal, whereas if I change it to glass, see denser to, sorry, if there is depends on the angle as well, denser to rarer medium. What can you say, what was this due to? See, this you can see there is no refraction happening, instead full light ray is reflected. You must be familiar with that concept. This is called total internal reflection. Total internal reflection, is that clear? See, but that depends on how much is the angle. If the angle is what you say sufficient enough, it will be refracted as well in addition to reflection, but otherwise if the angle comes like this, it will be total internal reflection to the same medium, to the denser medium itself. Okay. Now I will explain little more concepts about the refraction. So after refraction, we have about lenses. Which are the two types of lenses we have? We have lenses like convex lens is there, then we have concave lens. See, I will show you over here, you can watch on the board. Okay. So refraction, Snell's law, then I showed you the explanation of how the refraction happens. After that, the use of refraction, where do we observe refraction? You can see this. Okay. See, this is what kind of lens? A convex lens. Then we have a concave lens, two types of lenses. You know what's the lens equation? That also must be aware of, 1 by v minus 1 by u. This is v is the image distance, u is the object distance. There are two lenses and lens equation, and we have an equation for magnification which is v by u, image distance divided by object distance. And also you should be clear about the positions of object and corresponding positions of image. Where the object is, when the object is kept at a given position, there should be an image. You should, what all things you should be clear about, that is the position of object, position of image, and the nature, the nature of the image. Some places it will be real and enlarged, some will be virtual and enlarged, like that, depending upon the position. That part you have to be very clear, very well clear with. That is, say for convex lens, actually convex lens forms all different types of image. It forms real image as well as virtual image. It depends on the position of the object. Whereas if you think of concave lens, always it forms one type of image, that is diminished and virtual and erect images. Always all virtual images are erect images. Alright. So now again one thing we can make out is, you see this is the light ray. Just watch this. You can see the light ray is going from here. You can see the position of object and image. See, this is the focus. When the object is at focus, how the light rays are going? The light rays are going parallel to each other. That is, object is at focus means image is at infinity. But if the object is at infinity, then image will come to be at the focus, when it is going further and further. this is the object. You can make out. See, when the object is at focus, image is at infinity. See, the light rays are parallel. Okay, and if the object is between f and 2f, you see the position and nature of the image. If the object is between f and 2f, a convex lens forms real, inverted and enlarged image. As it comes towards this one, you can make out one thing. See, at this point is around 2f. So, when the object distance is 2f, image distance also 2f, and what about the size? It would be same size, real, inverted and same size. And as the object moves away, the image again comes closer and closer to the lens. When the object is beyond 2f, image will be between f and 2f. This, what is the cross mark shown over here, is nothing but the focus. Okay. Once again, when the object is between f and 2f, image is beyond 2f. When the object is beyond 2f, image is between f and 2f. Okay. So, that is the concept about lenses. All right. Now, again another aspect I want to tell you is, lens, first I said refraction. Refraction leads to the concept of lenses. Lenses, two types, concave lens, convex lens. The equation we have the lens equation as well as the equation for magnification. These are the two equations you be clear with, right? And magnification is simply nothing but height of image divided by height of object. Okay, that you must be knowing. Next thing is the convex lens is what is nothing but we have it in our eyes. So, how does our eye function? The function of eye, that actually you must be aware of the fact that the case of cornea, iris, retina, okay, all these parts you must be knowing, right. So, I will show you a small video to understand the concept of what is there in an eye. Okay, just watch this video. Watch this.
Sight, a precious gift we can't take for granted. Our eyes are windows. World. All we know and love, experience and discover, ponder and cherish. Let's peer into the workings of the eye, a unique and self-sustaining system. The reflected light of the world enters through the crystal transparency of the cornea, aqueous humor, lens, and vitreous humor to project onto the photoreceptors of the retina, whose impulses converge on the optic nerve, and then to the brain to be transfigured into imagery and imbued with meaning. Continual adjustments to the pupil and lens regulate the entry and focusing of light. In today's world, the eye's surface is constantly challenged to protect itself and adjust to changing conditions. Every blink helps our eye's natural defense system, the tear film, retain moisture and maintain visual acuity. Tears contain potent natural disinfectants to keep bacteria at bay. And the tear system washes away impurities to maintain eye health. The miraculous biology of our eyes inspires us to develop ways we can protect and maintain comfort for these remarkable structures. For all the wonders our eyes provide throughout our lives, we owe them our attention and ongoing care.
Hope you have watched this video. I hope you understood the construction of eye. So, in fact, we have the pupil to control the intensity of light. We have what else we have is the retina for the image to be formed, right, and the lens is there to focus. But basic difference between a camera and a human eye is that in a camera the focal length of the lens cannot be adjusted because it is rigid, whereas in eye the lens can adjust its size, it can adjust its radius of curvature, thereby it can adjust the focal length. What is the property of the eye called? Adjusting, we have to see the objects very far and objects close to you as well, for which what happens is in our eye, we cannot change the distance between the lens and the screen, that is retina, in our eye. So instead what the lens eye does is it adjusts with the help of the ciliary muscles, it will adjust the focal length, and by adjusting the focal length only the eye is able to see or get the image of the far away objects as well as closer objects. Okay, so but due to continuous use of eyes, as we get aged, you may what is the elasticity of the ciliary muscles may be lost. Because of that, we may not be able to see the very far away objects as well as very close objects. That problem of our eye is what is called presbyopia. So we have certain things to learn about the defects of eye. That is, we have the presbyopia, we have accommodation, we have the short-sightedness, far-sightedness, and astigmatism. These are the 4 problems basically we have in our eyes, the ones which you are going to learn. What all? The presbyopia, short-sightedness, long-sightedness, and again about astigmatism. So the defects of this eye, I will show you a short video. After a short break, I will show you the video, after which again we will discuss some questions. So my dear students who are in 10th standard, remember it's a live program. You can note down the things whichever you have problems on, and call us and find out what the solution is. And again, right now I'm going for a short break. After the short break, I will come back and we'll discuss a few things further. Okay, stay tuned with NTV.